Okay guys, so here we want some practice of putting it all together, putting all the things we learned together. So we have that power rule, we have the constant times a function rule, we have addition and subtraction rules, and when you combine those you can actually get this rule that tells you that the derivative of some constant, just like, so like the derivative of, if you had f of x equals 2, so if f of x was just a line like that, you'd know that the derivative of this function, that f prime of x, would be equal to 0. Alright, so that's just something to keep in mind as we do these problems here. So we're going to practice all these rules together. So the first problem is 7x to the fourth minus x squared. Right? So how can we do some of these rules? So notice that this first one is some constant times a function that we know how to take the derivative of. So we kind of know how to take the derivative of this whole thing, right? The derivative of this whole thing would just be 7 times 4x cubed, right? Because of that rule that tells us constant times a derivative, constant times a function is, if you take the derivative, it's constant times that same constant times the derivative. And this next part, we just know how to take the derivative of this exactly, right? This is 2x to the 2 minus 1. And since these are two functions that we know how to take the derivative of, we're just going to use the difference rule, right? So if we're taking the derivative of this whole thing, we're going to get the difference of those derivatives. And so here we'll get 28x cubed. I'm sorry, this 3 comes from 4 minus 1. And then we'll get minus 2x to the first. This next part here is a little bit trickier, right? We have the difference of two functions again. So we're going to want the derivative of this function minus the derivative of this. And we know that the derivative of that is 0 because of this rule here. But the derivative of this function is a little bit tricky. All right? It's not in the form we need yet. It's not in the form x to the n. And it's also not in the form some constant times x to the n. Right? We can't put that function that we know how to take the derivative of in brackets. We can't like put brackets around my x cubed because this is in parentheses. So how do I deal with these parentheses? Well, I actually have to distribute this exponent. So I'll get 2 cubed times x cubed, right? Which is 8 times x cubed, right? So all I'm doing right now, I haven't taken a derivative yet. All I'm doing is simplifying this function so that I can actually take the derivative of this whole thing. All right, so now it's a lot more like this problem, right? I can set this off in brackets. I have a constant times something I know how to take the derivative of, so I know how to take the derivative of this whole thing, and I know how to take the derivative of this. So if I take the derivative of this difference of functions, I'll get 8 times 3x squared minus 0, which is going to be 24x squared. Right. Let's do one more example, and remember this is 1 because of this 1 turns into a 0 because of this rule here. Let's do one more example where we want to find the first and second derivatives. Okay, so f prime of x, so we're going to basically use the same kind of idea we did above, right? We're just taking the sum and difference of a bunch of things, so we're going to get the sum and difference of a bunch of derivatives for our derivative. So f prime of x, remember I'm going to set these off in brackets, so I know how to take the derivative of this, I know how to take the derivative of this, and I already know how to do these two. This is x to the first, remember? So I'll get 4 times 5x to the 5 minus 1 minus 3, 2x to the 2 minus 1 plus 1x to the 1 minus 1 plus 0. And if I simplify this out, I'll get f prime of x is equal to 20 x to the fourth minus 6 x to the first plus 1 x to the 0, which is just 1, and then plus 0. I don't need to write that. So this is my whole first derivative. And I could even write that without the 1 there, right? It's just 6x. So now if I want to do another derivative, it asks me to take a second derivative. So I'm just going to take the derivative of what's here, right? So f double prime of x is going to be, I'm going to set this off in brackets, set this off in brackets, so I'll get 20 times 4x to the 4 minus 1 minus 6 times 1, x to the 1 minus 1. I'm just using that rule for x to the first, right? And then plus, what's the derivative of this, is 0. So my second derivative, if I simplify all this, will be 80 x cubed minus 6 x to the 0 plus 0, which is, if I just simplify it once more, we'll get 80 x cubed minus 6, right? Because x to the 0 is just 1. Okay, and you'll eventually start being able to skip over some of these steps and kind of just go from here to here pretty quickly, drop down the 4, turn the 4 into a 3, and then 6x is just going to be 6. But why I'm writing out all these steps in the middle is I want you to see that taking the derivatives right now is just based on some basically 3 rules that we know, right? This power rule, it's based on the constant times a function rule, which is right here, why I'm setting this thing off in brackets, and then it's based on the rules that tell us if you take the derivative of sum and differences of functions, you're just going to get the sum and difference of those derivatives.